Good day, viewers. Welcome to my YouTube channel, Maths with Adevic. My name is Victor Adewale Adeleke. Here, our major focus is to teach you mathematics from basic even up to tertiary institution. If you are yet to subscribe to my YouTube channel, do well to subscribe, hit the notification button, like and share. Okay, as we have here, we are having indices and logarithms, and over I think for them I've created a series that I've been teaching indices and logarithms consecutively. Now this, as I promised, that I will bring some questions that we'll be able to solve. Particularly, these are two wide questions and these are two jam questions that I promised that I will solve. Now, what you must understand, first of all, before we solve these questions, if you watch these questions, I made sure that I did not bring any question that is an equation. All these equations here, they are expressions. For my next class, I will start teaching logarithmic equations and exponential equations, which is for indices per se. Now, what you need to know is that there are always, every algebra is very useful. We have the equations, and we have expressions. Now, what are equations? If you have 5x plus 3 equals to 0, this is an equation. Why is it an equation? Because of the equal to, so it becomes an equation. But when we have those 5x plus 3 standing alone, this is called an expression because it has no word equal to. So what the only thing we can do here, we can solve for the value of x, but we can only simplify or evaluate. That's what we call it in mathematics. But in this case, now you can solve for the value of x because there's an equal to. You can follow the rules of algebra and you systematically manipulate out the answers. So that's what you want to understand. Now for this question here, our first question here, we're going to try that one. We said, assuming that log 4.4 is equals to, this is a question from JAM 1978, question 39. Assuming that log 4.4 is equals to 1.4816. We are assuming. So in case you punch this log 4.4 your calculator, like I said, this is a natural log which is base 10. A natural log base 10. I've explained in my previous class. If you have not watched it, go and watch it because it's very important so that you can understand what I'm teaching you. You see, assuming that log 4.4 is equal to 1.4816 and log 7.7 is equal to 2.0142. If you punch this your calculator, mind you will not get those figures. We are assuming here. Now they say find the value of log 7/4. So we are going to, if log 4.4 is equal to this and 7.7 is equal to this, then find log 7.7. I know many of you may feel like a very simple question. It's a very simple question. You can pause the video and try to solve the question. Then you find out that there are some problems in it. But today I took my time out to make sure that I explain the concept of that question 1. Now what do we do? The first thing we are going to do is just say log 4.4 is equals to 1.4816 and the other one log 7.7 is equals to what? 2.0142. Now what you need to understand is that what is 4.4? What to do 4.4? 44 times 0.1 will give me 4.4. If you point that to the calculator, you get that. So 44 times 0.1 will give me 4.4. And what will give you 44? 4 times 11 will give you 44. So it means 4 times 11 times 0.1 will give me 4.4. So instead of me trying to plug all these values into that or writing 4.4, I can just replace it with 4 times 11 times 0.01, which is still the same as 4.4. So I want to write this number 1 and this as it becomes log 4 times 11 times 0.1 equals to, we have 1.4816. Then the same goes with the other one, the other assumption. We will say that log 7 times 11 times 0.1, yes, will still give me 7.7 equals to what? 2.0142. Once you've done this, now the next thing you need to now do is want to eliminate. You use a method called elimination. So you say that this equation 1, I think you need to call it equation 1. This one we should call it equation 1. So this we call it equation 2. So if you are doing that, so you can also subtracting equation 2 from 1. So when you are doing that now, so we mean that everything here subtract what we have here. So we are going to have log. I'm just trying to follow the system of indices. There are other procedures that can provide a solution to this, but let's follow the system of logarithm and indices because that's what we are teaching. So log 4 times 11 times 0.1 minus log 7 times 11 times 0.1. Everything equals, I think I can put in the equation here, equals 1.4816 minus 2.0142. Now this is it. Okay, because we are looking for, we could do this anyways, because finally we'll get the negative answer because 1.48 is smaller compared to 2 points. So when you subtract this, you are going to get the minus answer. But let's try and do something like this. So I'm going to get, because I'm not taught that law. There's a law that I would have used to solve it, but let's quickly do it like this. Let's just change here to 7 and let's change here to 4. So we are still on point. Then 11 times this. We are still on point. So here we now have this. So I think I will need to see subtracting 1 from 2. Yeah, that's what I was supposed to say now. So once you've done that, we are still on track now. Now you will then see that equals to, so we are moving this one from this one now. So we have 2.0142 minus 1.4816. Once you have that, then you use the law of logarithms that I explained, the law of subtraction or division. Now, of subtraction or division, yes. But now what you need to understand here is, first of all, let's subtract this. Let's subtract that number. So we have 2.0142 minus 1.4816. Subtracting that is 12. 12 minus 6. 12 minus 6, we have 6. Here we have 3. 3 minus 1, we have 2. Here we have 1. So we move from here, we are left with 1. Here becomes 10. Move from here, becomes 9. Here becomes 11. So 11 minus 8, that's 3. Then we have 9 left here. 9 minus 4, we have 5. So points 1 minus 1, we have 0. So you have that this minus this is equals to this because I subtracted that now. So we can now say that log 7 times 11 times 0.1 minus log 4 times 11 times 0.1 must be equals to 0.5326. Once you add that, then remember the law of logarithm of the law of subtraction that I told you that log a minus log b is equals to what? Log a divided by b. So we're going to apply that here now. So this is representing a, this is representing b. So what are we going to finally have? This is going to be simplified. This is going to be simplified to become log 7 times 11 times 0.1 divided by 4 times 11 times 0.1. Then you have equals to 0.5326. What happens here? 11 cancels out 11. 0.1 cancels out 0.1. What do we have now? We have log 7 over 4 is equals to 0.5326. That was the question from 7 over 4 that we were told to look for. So we have systematically solved it, and this is the answer. So log 7 over 4 would be equals to, if log 4.4 is this and log 7.7 is that, then certainly log 7.4 must be equals to this answer. That's the answer to that question. Then about 2 questions, let's try about 2 questions. It said if log 2x is equals to, if log 2 is equals to x, express log 12.5 in terms of x. Very simple. All you need to understand is, what is log 12.5? Let's try to break down log 12.5. Now, there's a rule of mathematics that when you have 12.5, you can turn it to a whole number. Move out decimal point once. You now have 125 times 10 to the power minus 1. And the law of indices, x to the power minus 8 is equals to 1 over x to the power of 8. So we have x to the power minus 2 must be equals to 1 over x squared. If you have x to the power minus 3 must be equals to 1 over x to the power of 3. Just like that, and so on and so forth. So once you've known that, now that's what we're going to do there now. So 12.5 is equals to times 10 to the power minus 1. And what 10 to the power minus 1, as I explained, it will be 125 times 1 over 10. 1 over 10. So once you add 1 over 10 to the power of 1, So that's why we're just putting 1 over 10, because 10 in one place is 10. So 12, 125 times 1, we have 125 over 10. So it means that this log 12.5 is going to be log 125 over 10. And like I earlier explained, the law of logarithm, when you have the divisions, what do? We take it, we subtract them. So we have log 125 minus log 10. This is a natural law because there's no log. I'm not putting any log there. So it's a natural law, constant natural law. So with that, you know that this is 10 and this is also 10. So log 10, 10, as I earlier explained, must be what? Must be 1, because I explained that in my other class. That's why I always keep laying emphasis. If you have not watched that video, all the videos I've given part 1 and part 2. This should be part 3 now. Now, if you have not watched those videos, make sure you watch them so that you understand the system of operation I'm carrying out here. Now, you see, you have log 10, 10, you have 1 there. Now, what is this? This is 125. So, what do we have? So, we have this is 125. So, because we have 125 there, we are going to see log 125 is 5 in 3 places. That is 5 to the power of 3. So, we can now see minus log 5 to the power of 3 is equals to log 12.5. So I'm trying to explain that. Now once you've done that, what happens to this theory? I explained another law, I think in my other class, that c raised to the power of a must be equals to, the a is inverted to the back, so we have a log c. So that's what's going to happen here. So this 3 is going to be inverted to the back. We now have 3 log 5 minus 1. So we are systematically bringing out the solution to that question. Once we've done that, now let's move on. Now what will give you log 5? What will give you log 5 is very simple. We have that 10 divided by 2 is 5. So we can expand. We can also write 5 by writing 10 divided by 2, because there's no expression given for log 5 from the question. So we have to be. That's what mathematical liberty must be. Smartly manipulative. So what we're going to do now, we're going to say log, instead of log 5, we're going to say that this should be equals to 3 log 10 divided by 2. Then we have your minus 1. Now once you add your minus 1, very simple. Then you can now say what? You can now say 3 log 10. Put in brackets minus log 2, then the minus 1. Then once you've done that, what is log 10? Do not forget, log 10, this is a natural log, so it has the 10 here also. And log 10 is 10, because log n is n in my other class I earlier explained, must give you what? Must give you 1. So we have 3, then you have your 1 minus, what is log 2? It was giving, so the expression was given. So we would have said 6 divided by 3. Also, and the work will continue forever, but no, but they gave us an expression for log 2. So because we were given an expression for log 2, the expression for log 2 is x. So we have minus 1. So you open the bracket, we have 3 times 1, we have 3 minus 3 times 8, we have 3x minus 1. So when you subtract that, this 3 minus 1 directly, this is the same as 3 minus 1 minus 3x. So once you've done that, 3 minus 1, you have 2 minus 3x. So this is the answer for log 12.5. Once you add that, this is just as simple as it looks. Very, very simple. Just understand the system of operation of logarithm, and that is all and all. So once you've done that, let's quickly try the third question. Let's really try the third question. The third question is an indices question or an exponential question. Now, these are two wire questions also that we are going to attempt. They are not really difficult as it looks. Just understand your rules and everything pours down as a pack of cards. So we have question 3. So we have 3 times 5. 3 raised to the power of minus 5n times 27 raised to the power of n plus 1. All over was 9 to the power of 1 minus n. Now what do we do here? Very simple. Just simplify with a normal procedure or a normal math. So what we are going to do here is that simplify the numerator first using your law. So the law says that I think in my first class I explained this, the first class under logarithms. I explained this theorem, I proved out this theorem and I explained how it happened. This is a very simple question, it's not really difficult. So what we are going to do now, we are going to say what? 3 raised to the power of minus 5n times the base has to be the same, because the law that we already know is that x raised to the power of a times x raised to the power of b must be equal to x raised to the power of a plus b. This is the law we've already known. So we have to make sure that these two x are the same. That's the only prerequisite for this theorem to work out. So that's what we're going to do. So we have to make sure that this 27 is the same as 3. So we already know that 3 in 3 places, 3 times 3 times 3 will give you 27. So I can say 3 raised to the power of 3, then you have your n plus 1. Then divided by, I have to also make sure that this works the same, because another law says x raised to the power of a divided by x raised to the power of b must be equal to x raised to the power of a minus b. So that's what we're going to do here now. So we are going to say 3 raised to the power of 2, because 3 in 2 places will give me 9. Then we have 1 minus n. So let's try to break this down now. So we can take it up, but whenever you're taking this number up, or let's not get there yet, let me not confuse you. So let's flow like this. So we have 3 raised to the power of minus 5n plus, why is it plus? Because the law of products say when you have 2 bases having the same powers, they sum up. So that's what we're going to do. So the same base having different powers, they sum up. So we have 3n plus 1, then divided by 3, 2, 1 minus n. So this is also equals to, open this bracket, so we have 3 minus 5n plus 3 times n, we have 3n. 3 times 1, we have plus 3. Then divided by 3, 2 times 1, we have 2. Then 2 times minus n, we have 2n. So we have minus 2n. Once you add that 2 into that is 2 times 1, we have 2 times minus n. We have minus 2n. Therefore, you cannot use your law of subtraction or division for indices. So we cannot say that therefore this must be equal to what? 3 raised to the power of minus 5n plus 3n plus 3, then minus, but mind you, when you are putting your minus, the minus affects the denominator, so you have to put a bracket there. So we have minus 2n. So let's try and simplify. So this 3 raised to the power minus 5n plus 3n plus 3 minus 2 minus times minus plus 2n. Once we've done that, now we can now solve the simple arithmetic. Minus 5n plus 3, minus 5 plus 3 is minus 2. So we have 3, so the answer, these are the answers coming out. So we have 3 raised to the power of minus 5 plus 3, we have minus 2n. Then 3 minus 2, we have plus 1, we have plus 2n. So what happens here? This strokes out this. Yes, it strokes out what? This. Because why? Because minus 2 plus 2 is 0. Minus 2 plus 2 is same as 2 minus 2. So we have 0 there. So this one is already out of the box. So all we have here is 3 raised to the power of what? Of 1. And what do we have? 3 raised to the power of 1 is what? Is 3. So your final answer to that question 3 is 3. So once you add that, let's quickly solve the last question. Let's quickly solve the last question. Now the last question is, they say simplify 5 to the power of x, but also simplifying. So this is number 4, which is the last question that I promised to solve. 5 to the power of x times 25 to the power of x minus 1 over 125 x plus 1. Now what do we do here? Very simple. Very simple. What you need to understand here is that just say that the same thing I did here. Try to make sure that this base and this base are the same. So we have 5x times 25 is 5 is equal to x minus 1. Then we have divided by what? 1 times 5 is 5 is equal to 3. Because 5 times 5 times 5. 5 times 5 25. 25 times 5 will give you 125. So 3x plus 1. Now what do we do? The law of indices that I explained in my other class, we are going to apply it here. So I'm going to say that therefore we have 5 is equal to x plus 2x minus 1. So divided by 5 is equal to 3x plus 1. So from here what do we do? 2 times x, let's expand the power. So plus 2 times x, we have 2x minus 2 because 2 times minus 1. 2 plus positive times negative is negative. So 2 times minus 1, 2 times 1 we have 2. That's that. So we have the same thing applied to the denominator. 3 times x, we have 3x plus 3. 3x plus 3. So once you've done that, now what do? You can now take your normal law of division. So we have 5 is equal to x plus 2x minus 2 minus, don't forget to put your brackets, like I stated down there, 3x plus 3. So what do we have? We have that 5 is equal to x plus 2x minus 2. Minus times, there's a positive sign here. So minus times positive, we have a negative 3x. Minus times another positive, we have a negative 3. Now what do we do now? We group them. X plus 2, we have 3x. I think it's going to be the same. So we have 3x minus 2 minus 3x minus 3. So 3x cancels out what? 3x. Minus 2 minus 3, we have minus 5. So 5 is equal to minus 5. That's what we are going to have. So finally, this, because the law of indices says x raised to the power of minus a. Let me explain. I explained it just now, but let me just write it. It's equal to 1 over x raised to the power of a. So what do we have there? So you can leave your answer like this, you are still correct, but you can simplify, or you can also show that therefore finally your answer is going to be 1 over 5 raised to the power of 5. So that is your final answer. Or 5 raised to the power of minus 5. Or you can punch that your calculator and put it as a denominator. So that is just that for that. This is all about logarithm and indices. Very, very simple. You just need to understand it. It's not difficult at all. Now, like I said, this is logarithm and it has been explained, and indices also have been explained. So in my next class, I'll be focusing on solving problems that are logarithmic equations and exponential equations that are even more difficult or coerced than this. And before that time, stay tuned. Do not forget to subscribe, like and share this video. It's very important so that when I post videos like this, you always get notified. Good day and God bless you. Stay tuned.